Good afternoon, everyone. On behalf of the College of Forest Resources, I wish to welcome all of you to this 12th Denman Forest Reissue series entitled Water Supply and Stormwater Issues in the Pacific Northwest. We look forward to an exciting and informative program today as we investigate a series of issues dealing with stream flow prediction, climate change and its effects on water supply and water storage, water rights, balancing water usage between domestic, agricultural, and conservation uses, and the role of forest and forest restoration in relation to water issues. The purpose of the Denman Forest Reissue series is to provide information and discussion on timely forestry and natural resource issues. As with all activities associated with an academic setting, our ultimate goal is to inform and educate our students, faculty, and staff, as well as resource professionals, landowners, and the general public. These programs are made possible through the generous support provided by the Denman Endowment for Student Excellence in Forest Resources, and they support the college's vision of being a world-class and internationally recognized source of knowledge relevant to environmental and natural resource issues. The mission of the College of Forest Resources is to study and investigate the sustainability and functionality of complex natural resource and environmental systems in both natural and managed environments using an interdisciplinary approach across multiple spatial and temporal scales to include our urban, suburban, and wildland landscapes. In our college, we focus on programs in sustainable forestry, sustainable urban environments, and sustainable forest enterprises. Sustainability serves as the goal for all of our programs and includes all resources, such as trees, plants, water, wildlife, or insects, for example, considers the needs of future generations as well as those of the present, and strives for a dynamic equilibrium that balances ecological functions and conditions with social and economic factors. Today, our topic is devoted to the investigation of a series of water-related issues of high importance to those of us who live in the Pacific Northwest. Current and future water supply issues are and will become even more important as time goes by. In the Pacific Northwest, water supply is largely controlled by two factors, geography and seasonal weather patterns, wherein about 2/3 of our precipitation occurs between October and March. These two factors, geography and weather patterns, combine to produce high variation in precipitation across the region, for example, from the western slopes of the Olympic to the eastern slopes, and between major river basins. Some of our rivers are highly influenced by snow events, some by a combination of snow and rain events, and some of the lower elevation river systems are highly influenced by rain events. That's what's depicted on this graph. The red line depicts a snow-dominated river system showing normalized stream flows over the months October through the hydrologic year to September, with peaks in June and July, whereas a rain-dominated, the blue line, peaks much earlier in the year in November, December, and then stream flows drop off. So there's high variation just due to the type of river system that we're talking about. Most of our power, irrigation, and domestic water supply originates in the forested watersheds of the Pacific Northwest. So maintaining our forest as healthy, working forest is essential to a sustainable water supply. The UW Climate Impacts Group has been looking at possible changes in the Pacific Northwest climate as a consequence of global climate change. And this slide just hits the very top summary items. Some of the things that we expect to occur over the next century include warmer temperatures, wetter winters, and reductions in snowpack as a consequence of those warmer temperatures. And because of all that, and thinking back to the previous graph, earlier peaks spring runoffs. The Climate Impacts Group also has looked at possible implications of climate change on our Pacific Northwest water resources. A couple of conclusions are that many rivers will see changes in peak flows between winter and summer. Salmon will suffer if summer flows decrease and water temperatures rise. And low-lying coastal areas may, in fact, be flooded as rivers and oceans rise. And lastly, we expect increased conflicts over water rights and water usage to occur, and increased urban demand for water relative to agricultural demands. Today, we have a group with us to address these and other complex issues. Our speakers are drawn from city, county, state government. Our topic, once again, is water supply and stormwater issues in the Pacific Northwest. And our moderator is Bob Edmonds, Associate Dean, UW College of Forest Resources.
Our first speaker in this session is Dan Swenson. Dan is the Department of Ecology's Water Resources Program Section Manager in the Northwest Regional Office. He is a 1970 graduate of the University of Washington, and he's held his current position for the last 8 years and has been with the Department of Ecology for 25 years. The title of his presentation is Water Rights Issues in Washington.
Thank you. It's a pleasure to be here this afternoon. I certainly enjoyed the presentations by the faculty from the university. I want to really bring up about 3 general areas, talk about water rights in the state of Washington, some of the issues associated with those, what is a water right, talk about some of the water right management challenges we're facing, and then a few thoughts for the future. And then during the question and answer period, hopefully we can get into a little bit more detail about some of these issues. The kind of business we're in is really, it's a funny business. On some days, we're dealing with this. We've got water everywhere and fish running up the streets, and things are great and kids are having fun. Then sometimes of the year we're dealing with this, a very dry and barren situation. So it's a little bit tough to sort of try to manage in this kind of dynamic environment. And certainly we hear about some of the challenges we're facing in the future from climate change and other things, but we certainly see it every year. So water rights and time. This is something that's been going on for a long time in the state of Washington. We certainly go back to the late 1800s when we were having treaties established between the United States and the Indian tribes in the state of Washington, and the whole concept of a reserved right came out of that time frame. In 1873, the territorial government was passing laws related to water rights and established at that point the prior appropriation system, which is first in time, first in right, which has stood the test of time so far, but as I will note later, I'm not sure it's the test that and the standard we want to use for the future. In 1917, the state adopted the Surface Water Code, which basically said that all diversions of surface water from the state for beneficial use required a permit from the state of Washington. And that was when we really got into the permitting business. In 1945, it was expanded to groundwater, and groundwater withdrawals were required to get a permit as well. Now, there is an exception in the groundwater code for small uses, less than 5,000 gallons a day. They do not have to come to the State Department of Ecology for a water right. They're exempt from the permitting process. And then the last major change to the state's water code was in 1971 when the Water Resources Act was passed, and this basically established a number of water management principles for the state of Washington. There have been certainly a number of other amendments over time, but those are really the 1917 amendment to the code, or the establishment of the water code, the 45 groundwater adjustment in the 1971 were the main legislative acts. Now, the water code itself, this is really what I deal with on a day-to-day basis. And really, it's a set of general principles to be applied to a set of facts. That is, a water right application that comes into my office or one of the other regional offices for a decision. Now, 2/3 of the water code is not in statute. It's common law through case law. And anybody that's followed water resources issues in the state of Washington know that it's filled full of litigation. There's many a career built on litigating over water rights issues, and at least for the foreseeable future, I don't see that changing, and it's certainly a part of my business, not on a daily basis, but quite frequently decisions that we make get appealed through the court systems and often to the state Supreme Court for final resolution. So it's a layer cake compiled over 120 years, and that often makes it difficult to deal with when you're looking at case law that's evolved, a code that has been amended over time, and you get things layered on top of one another, and you read the code and you just can't make sense of it. When you have a legislature that's trying to fit a particular solution into a code, it often doesn't work very well and makes our life very difficult. One thing about the water code, it says all uses are equal. There is no prioritization. The only priority, again, it comes back to the first in time, first in right theory. So a beneficial use for a nuclear plant is the same as a beneficial use for a 1,000-acre farm or a municipal government's water rights. They're all the same in the government's eye from a use standpoint. And one of the natures of the system is that it's intended to over-allocate the resource, which is kind of odd, but that's the way it was built. And basically it says that junior rights, those that aren't first in time, have to shut off when water is short. So you may go into a basin and you find that it's over-allocated from a water rights perspective, and the thought is that ideally you would adjudicate that basin, which means that you would come through and affirm the value of those rights. And then when the water was short, those last in time would have to shut off for those first in time could fully exercise their right. That works wonderfully well for those who have the first in time right, but not so well for those that come later. And particularly thinking about it in terms of in-stream flows and beneficial uses that we're trying to protect in our river systems. And then there's no limit or no recognition of GMA, the Growth Management Act, the Endangered Species Act, local watershed plans, or the public trust doctrine in the water code itself. So what is a water right? One, it starts with an application. A person that wants to make the beneficial use of water has to come to the Department of Ecology, again, unless it's for one of those small groundwater uses. And that really establishes an intent. It's an intent to appropriate the state's waters, and that's the first part of the process. That costs you a whole $50 in the state of Washington, and it's just gone up from $10. So we're dealing with an extremely valuable resource, but somebody can come to the state with a $50 check and potentially get a permit for the use of that water in perpetuity. We're probably not valuing that resource very well. Then the second part is basically a permit, and that's what the state gives for a person to develop their project. They're given a development schedule, and they say, go forth, build your project, put the water to a beneficial use. After you've put the project to a beneficial use, you basically have to proof up that use, and that's called a proof of appropriation. And that's where you come back to the department and show us the amount of water that you've used, that you've done it under the conditions of that permit, and if you've done so, then we'll grant you a certificate for that use. And that certificate then becomes a property right to that person. And then there's a process, you can come in and change your water rights to change a purpose of use or a place of use or something like that. And then if you do not use it, there's a concept called relinquishment, where if, for example, if you have not used your water right for a beneficial use for over a 5-year period without some particular excuse for that use, you can lose that water right. Or if you do not use it for an extremely long period of time, it's subject to common law abandonment. Okay, water right permits. Ecology must determine 4 things when we go through a water right permitting process. One, that the water is going to be put to a beneficial use. I've touched on that. That water is available, not only physically available, there's water in a stream, or that there's groundwater available, but also that it is legally available. That existing water users will not be impaired. Again, coming back to the first in time, first in right, you cannot issue a new water right that would impair a senior water right holder, such that if you put a well on your property and that well would take away the water from your neighbor's well, that would be an impairment of that right, and we do not do that when we issue new permits. And then it must not be detrimental to the public interest is the fourth criteria that we use. Okay, the alphabet soup of water rights, the P's and Q's. Every water right has some P's and has some Q's. It has a point of diversion or a point of withdrawal. A point of diversion if it's out of a surface water right like a lake or a stream. A point of withdrawal is a groundwater withdrawal point. A purpose of use, again, it could be for agricultural irrigation, municipal use, commercial use, industrial use, something like that. A place of use, that defines the geographical boundary that the water can be put to use, whether or not it's your farm or your municipal community or your factory or what have you. And again, it has that ever important priority date. And then it also has some Q's associated with it. It has an annual quantity, which is in terms of an acre foot measurement, and that would be like 100 acre feet, 1,000 acre feet, or what have you. And an instantaneous quantity, which for surface water is in cubic feet per second and groundwater is in gallons per minute. Okay, and as we work through the whole issues of water rights, we're facing some challenges, and many of them you've heard today, but clearly we're facing challenges in terms of population growth. If you look back when the Surface Water Code was adopted in 1917, we had about 1.5 million people in the state. And also you think about the state's economy then, it was much different than the economy that we're dealing with now. In 1971, when the Water Resources Act was passed, 3.5 million people in the state, 6.3 million today, and we're projected to be at 7.5 million by 2020. And then we're certainly eastern and western Washington, we're seeing population growth on both sides, even though there's certain different economies there, but we're facing certainly water supply pressures, and the growth rates are relatively similar. Also, in terms of numbers, endangered fish, we have over 20 listed salmon and trout steelhead runs. We have 16 over-appropriated basins where stream flows are critical to recovery, and we have seven major salmon recovery areas, which really cover much of the state of Washington. This is a map showing the 16 salmon critical basins in the state. You can certainly see it's not only the west side, the east side, the Olympic Peninsula, so we have major challenges all across the state. Okay, some of the numbers around water rights. We currently have 6,500 pending water right applications, and including over 1,000 change applications. So we have a tremendous backlog, and that's certainly frustrating to a lot of the public out there that have been waiting to put water to a beneficial use. So it's a real challenge for the state in trying to manage its water and meet the economic needs of the state when we have such a water right backlog. We drill about 8,000 new exempt withdrawals a year. Again, those are groundwater withdrawals. They're not subject to water right permitting. So basically, they're outside of the direct purview of the Department of Ecology, and I think Dave will talk a little bit about that and what he sees in King County. We have over 170,000 unadjudicated water right claims. Claims are a way that people that were putting water to use before 1917 for surface water or 1945 for groundwater could document their use. And the only way those can really be firmed up is to go through an adjudication, which is managed by a superior court. We've had some adjudications in the state, some small ones, and there's been a large one going on in the Yakima Basin for over 20 years. But we still have, as you can see, a very large number of water rights or claims for water rights out there that we have no certainty around. So it really creates a difficulty in trying to manage the state's waters when you have this much uncertainty in the system. So there's just a table, or actually a pie chart, showing you the relationships between all this uncertainty and where we do have some certainty around certificates and permits, and then the backlog of applications. Some of our water management challenges, and I'm going to move through these rather quickly. We need to have water for growing communities. A map of the central Puget Sound area, obviously a lot of population growth here. I think over time we'll start to see a more conjunctive use management system in the central Puget Sound Basin that is starting to connect water supplies in the north up in Snohomish County and water supplies in the south. And I think over time you'll see more of a grid system in this region to deal with this growth and make more efficient use of our water supply. Water for growing our economy. the Columbia River Basin and all the demands we see on the east side for agricultural uses, water for fish. This just happens to be a chart showing on the vertical axis is a number of smolts. On the horizontal axis is a flow index, but basically it shows the greater amount of flow that we see in this particular stream, the greater amount of smolt production, and obviously the benefit from the higher flows and the cooler flows in the summer compared to the lower summer flows. And water's not where we need it and when we need it. We have limited storage and conveyance, and we don't have a very large reuse infrastructure system in place at this point. We've seen a similar chart earlier. This is, again, our water use compared to our rainfall and the challenges we face around storage and trying to capture that winter rainfall, either on in-channel kind of storage behind dams or off-channel storage, or in the future, I think we'll see more aquifer storage and recovery of using the ground as a storage mechanism. Development certainly affects flows. This is a graph showing what happens with major changes from urbanizing land use. The light blue bar there is runoff before you see major changes in land use, and then after heavy urbanization, the change in more runoff and less recharge to our aquifers. Withdrawals certainly affect flows. Basically, it's a busy graph, but it shows that as we increase our groundwater withdrawals, our low flows start to be an impact of that. Dams. This is a graph showing the flows below the Dalles on the Columbia River, pre-dams, post-dams. You can see how the flows have been dampened out, and certainly as the flows get dampened out and we lose those peak flows, that certainly has an effect on the environment for wild salmon. And if you don't have enough water, you're going to have to find ways to make water. And some of this can occur through use water more efficiently, water conservation, water reuse, store water for when it's needed, and then move water. And this is more of the conjunctive use, share our supplies, develop our conveyance system, and use the markets. So in terms of making water, conservation requires certain changes in behavior. I think this region has done very well in accepting those challenges. Reuse is going to require capital investment in treatment and distribution, but I think it's the wave of the future. And then certainly storage. It's missing. It's single purpose in some basins, and we certainly need to do better, but there are environmental issues about capturing those waters, particularly out of our streams. Now, just quickly touching on a preferred future or a vision. One thing we can think about is establishing a natural resource base, and this is making sure that we have adequate water for properly functioning watersheds, both water quantity and water quality, and it's going to be important that we lock up a natural resource base for future generations. I think we're going to look at more of a water marketing mechanism. We aren't going to be issuing a lot of new water rights. We need to manage with what we've got and use the market to distribute the resources that we've already allocated. Information-based water management, we need to do a better job of capturing water that's being used to monitor our systems and use that for future water management decisions. And I think there's going to be more shared governance, not only between state government, local governments, and tribal governments. So in summary, I personally do not believe our current water resources regulatory structure is well suited for the challenges we face over the next 100 years. Prior appropriation may have worked well for the past 100 years, but I think the challenges we're facing now, I think there's going to have to be a serious look at how we manage our water. And our future water management system must sustain both our local communities and our natural systems. Thank you very much.
Our next speaker is David Monthy, who is the Regional Water Supply Analyst with King County, where he's been for 5 years. He has a BA in History from Yale University and a law degree from the University of San Francisco. He works on water policy issues related to water resource management, including reclaimed water, in-stream flows for fish, water utility operation and planning, water conservation, groundwater protection, water legislation, and regional water supply planning. He's worked at the State Department of Health Office and was counsel at both the Washington State Senate and the California Department of Water Resources. The title of his presentation is Balancing Water Uses in King County, Managing Water for Urban, Domestic, In-Stream Flow, Agriculture, and Other Uses.
Here's what I'd like to talk about in my presentation. First, a little bit of background that I'll probably go through pretty quickly because you've heard some information already on King County circumstances and Puget Sound region circumstances and conditions. A few challenges to King County and the rest of the state with regard to water supply. A few ideas around how to meet some of the needs that we've identified that we'll be having to deal with. In particular, I want to talk about the Regional Water Supply Plan, which is something King County has been advocating for several years, and it looks like will actually be underway here shortly. And then some observations and final thoughts after all that. The topic of my presentation has to do with balancing and only talking about a few of the many potential uses of water. It did occur to me that we need to be thinking about, when we're talking about balancing, what exactly we're balancing. Are we balancing one need against another? Somebody wins and somebody loses. Are we balancing certain values against other values, certain priorities against others? Is it the first in time, first in right versus the latecomer in-stream flow problem? Second, who does the balancing? I mean, one of the problems, and I'll touch on that, is the question of who's making decisions around water supplies is something that I think is going to become a major focus in the next few years. How does the balancing change over time? As Dan mentioned, the Water Code was adopted in 1917. The Water Resources Act in 1971 really began pushing in-stream flow protection. There was a long period of time when in-stream flows really didn't have much legal protection. That reflected a change in values. There's an evolving sense of values now. So the balancing is going to change. And then is balancing really the right question? More on that. King County watersheds, you've already seen a few maps. This adds maybe a little bit to your understanding, a little bit of information about just how large some of the watersheds in King County are. I don't particularly want to get into the detail here. This is just an attempt to illustrate how complicated water issues can be when you've got a land use pattern that's very complex. The large green areas in the eastern part of King County are, of course, forests, and one thing, as you heard earlier, that we need to make sure we do is to protect those forests because they provide a lot of functional value to water supplies as well as to the general ecosystems that we have in King County. Personally, I think the largest challenge to us in this county with regard to water supply management is the governance issue. Just to illustrate, again, the complexity, there are 39 cities in King County, most of which have their own water utilities. Some of them are supplied by water districts. There are multiple water and sewer special districts in addition to the cities themselves. Within King County, the watersheds overlap with some adjacent counties, so if we're talking about management on a watershed scale, we have to talk about other county governments. We have 6 tribes with their usual and custom areas under their treaties. Federal agencies with different responsibilities under various federal laws. Ones that have gotten some prominence lately include NOAA and the U.S. Fish and Wildlife Service with regard to implementing some of the Endangered Species Act provisions that you've already heard about. Multiple state laws, the Growth Management Act, particularly important to King County, and local jurisdictions in the business of land use. But there are other water resource laws. Dan mentioned the one specifically that Ecology implements, but there are others. And finally, there are lots of lawsuits, and I like to talk about those, but I'll mention a couple in a bit. A few kind of key facts to me. Again, I just mentioned that the main stem rivers have dams. Primarily water supply in King County, but also flood control and hydroelectric functions. What we are hearing with regard to climate change, and we didn't get much into that with the presentations earlier, is that those are likely to create some competing needs. Climate change and those changes are likely to create competing needs with regard to how those dams are operated. The needs of a system for water supply may run up against flood control. And although we already have those conflicts now, those conflicts are going to become exaggerated and magnified with climate change. In King County, surface water sources supply 70% of the water supplies, primarily Seattle system. They all have ESA-listed species, Chinook and bull trout, and other significant species. And I'll show you a map later that shows you ag lands. They all have, all the watersheds have significant ag lands. How's water used in King County? You know, the first bullet is just kind of the population growth that we're looking at. There are a lot of people, well, there were 1.77 million in 2003, and I just heard from someone at the Regional Planning Council yesterday that the official forecast is up over 3 million by 2040. We have multiple water systems, 217 federally regulated water systems in King County, another 1,600 water systems that meet the state definition. Another 12,000 plus, we don't really know how many individual wells in King County for drinking water supply. As I mentioned, the Seattle system is the largest system, serving about 1.3 million people, but 30% of the people in the county get groundwater, use groundwater for their source of supply. And there's a bunch of other wells. We don't know how many wells there are in King County exactly. Just in terms of how the population is served, and we're into the water supply portion of this presentation. Here's how it breaks down in terms of who serves the population in King County. King County gets most of its water from Seattle, but the water and sewer districts actually supply a fair amount of water, which a lot of them get from Seattle on a wholesale basis. But there are other cities delivering water from their own supplies, as well as just individual businesses and private wells. Won't get into the detail here. This is just to make a point that the number of wells in King County that are used for water supply is large. They're everywhere, and we're not exactly sure what most of them are doing most of the time. A few just kind of pieces of anecdotal information about groundwater in King County. We don't have a real comprehensive sense of what groundwater there is in King County and how it's being used. Anecdotally, we know that periodically there are problems with groundwater supplies. A couple that I mentioned are Auburn and Rock Creek, wells in those areas that went dry in 2003. Other areas that are known to be water deficient. Vashon Island has a major concern about mining of groundwater, and we're doing a significant analysis of their groundwater supplies, as well as some countywide ambient monitoring. In 2001, a group of utilities did a countywide assessment and a 3-county assessment of our existing supplies and forecasted needs, and concluded that there were going to be a number of supplies, including, I believe, 24 water systems that were going to be out of water by 2020. Wells continue to be drilled, and we do have what are called groundwater management areas in King County, but they generally are not supported. The exempt well issue that Dan mentioned, you know, from water resource management issue continues to be a problem in certain parts of King County. The next couple of slides just show how many wells, these are very small wells that don't require water rights, but in certain parts of the county where they're drilled without necessarily any concern for the impact on either the streams nearby or any other wells nearby, they can create some problems. So this just illustrates the number of irrigation wells that, you know, from the year 2000 that began to be drilled in King County took a leap. Similarly, small domestic wells, there's a large number of them that are being drilled today and over the past several years have been drilled, which again create a management problem in King County. Moving on to fish, we've had a little bit of discussion of this. There are some parts of King County where analyses of fish habitat as part of our recovery planning show that low flows continue to be a problem in all the watersheds. Groundwater is a contributor to flows and is a contributor of cool water, which is important to fish. Certain tributaries have well-documented flow problems, including the Sammamish, Issaquah Creek, Bear Creek, and Rock Creek. The main stem rivers, Green River and Cedar in particular, also the Tolt, have standards that have been applied to them or agreements that have been reached by the utilities that have dams on them to maintain certain flows in order to either avoid ESA implications or to keep their hydroelectric license. But in general, we don't have a comprehensive picture of where and how groundwater affects flows for fish. We do have some small studies like the MGFI, Middle Green Flow Investigation, that shows there have been impacts from groundwater, and only bits and pieces of water discussion in the salmon recovery plans that have been developed in each watershed. Moving real quickly to what we know about ag. So there are certain options that ag users have. And all of them are expensive to one degree or another, and this is a list. So what do we know about uses of water in King County? Well, we know a lot, but we don't really know enough. There's been no real demand forecast done for the entire King County area or for the regional area for water demand for the next 20 years. We know from the Outlook report that I mentioned that the utilities produced in 2001 that there may be at least 20 utilities that may be running out of water by the year 2020. Some of them have come up with new sources of supply. Some of them still don't have new sources developed. The recovery plans, which have just been developed in each of the watersheds in King County for ESA-listed species, are very good plans, but they have a big hole, and that's water. They have not addressed the water-related issues, by and large, that are facing the fish. And in terms of ag, we have a lot of data regarding agriculture, but little understanding of how existing ag uses require water and how prospectively they may need it in King County. There are also mixed signals that are being delivered on water, and I mentioned a few here. Technically and legally, the basins in King County, by and large, are closed to new water rights. They were closed by rules adopted by Department of Ecology in the late 70s and early 80s. But these exempt wells that I showed you graphically and that Dan mentioned continue to go in. And it's, in certain parts of the county, a problem now and will continue to be a problem. An example of the problem we find with drought conditions when we have multiple people purveying water is that there was a formal drought declared statewide this year. Seattle was able to capture enough water by July 1st to be able to tell its customers that they were in good shape and essentially rescinded their advisory on July 7th. But in the Sammamish River, the flows got to near historic lows on August 4th. And we were having to scramble to try to do things that we could do to try to make sure that those flows didn't get even lower and temperatures get higher, which was really important to fish, which were about to migrate. The state is committed to what they call the PEP program, which is Preservation Enhancement Program for in-stream flows. At the same time that relatively recent changes in state law sanctioned large quantities of water that municipal water supplies have in their water rights certificate that they haven't used. So we're trying to enhance in-stream flows. At the same time, we're also expanding the potential uses of municipal water supplies. And I just kind of refer to that as maybe the too many cooks kind of problem. This is an illustration of the governance issue. This is a map showing the largest water utilities in King County. When you have Dr. Palmer talking about regional solutions, this is what you're talking about, is getting all these suppliers sitting down and having a discussion about how do we respond to some of these challenges. The numbers just can become overwhelming. So in my view, what are the problems? Nobody really is in charge at either the state or local levels. And that to me is the overriding issue. Secondarily, the political will doesn't really exist to take tough steps, for instance, enforcement against illegal use. We know that there are illegal water users in King County and around the state, but what happens when you try to take some action is it quickly becomes a political football and other things happen, so it's not a pleasant thing to do. Collaborative processes, like I mentioned, the salmon recovery plans frequently sidestep the controversial issues like balancing in-stream flows versus out-of-stream water supplies. Land use and associated problems seem to be intractable. Development's occurring, there doesn't seem to be anything we can do about it, and there are problems that are associated with it. How do we deal with that? Well, we tried that in King County with the Critical Areas Ordinance, and it was a real challenge with regard to property rights. In my opinion, litigation may play a constructive role. I mean, it may actually enable us to get some clarity around certain issues that are legal issues. And in my opinion, the more I find out about climate change may end up dwarfing all the other issues. There are a number of things that the county is doing, ranging from updating its comprehensive plan, putting in some new provisions that provide a little more rationality to how water is delivered. We got agreement on October 31st with a broad group of stakeholders to initiate a planning process, a countywide planning process. And there's been a letter sent to the council and the executive saying, let's move forward. It will include technical work on multiple topics. I mentioned a few here, but it definitely will include climate change, demand forecasting, fish needs, and the small well issue, with that work to be completed hopefully by sometime next year, and then the planning process initiated and completed in 2007. Final observations: is balancing the right question, or is it better management? In my opinion, there are a lot of things we can do without necessarily having to make trade-offs, just in better management of our water supplies. That's it. Thanks.
Our final presentation will be given by David McDonald, who works for the Seattle Public Utilities, where he researches, writes about, and teaches environmentally friendly landscape practices. He's a biologist by training and has worked in oceanography, mountain lion research, and forest fire management, operated a small farm, and taught agriculture and forestry with the Peace Corps. He's heavily involved with public and professional education programs, including Seattle's backyard composting program, a model now used around the world that he helped create, natural lawn and garden care, and the Regional Soils for Salmon initiative. He's published numerous articles on landscape design and management and on soils and stormwater, and his current work focuses on the critical function of soils in urban resource conservation. The title of his talk is Stormwater and Water Supply Challenges in an Urbanizing Region, the Role of Soil and Forest Restoration in Sustainable Landscapes. David.
Thank you, Bob. We've been talking a lot about water supply and also flows and stormwater. I'm going to focus more on stormwater and try to, through pictures and discussion, make it a little bit more real and concrete to you, and also suggest at least one set of strategies involving soil and forest restoration that we can take. As the Pacific Northwest becomes more populated, we've been turning forest lands into urban areas at a record rate. This impacts things that we care about: our rivers, streams and lakes, our water supply, and native wildlife like salmon. To help reduce these impacts, we can adopt some simple soil and vegetation restoration practices, both for new construction and in our existing urban landscapes. Let's start in the forest. What happens as we turn our spongy native forests into towns, suburbs, and cities? This satellite photo analysis of our region helps us understand the change. The green represents areas with 50% tree canopy cover or more. Black is less than 50% trees. 1972 data on the left, 1996 on the right. Between 1972 and 1996, the amount of land with at least 50% tree cover in the Puget Sound region decreased by 37%, and that trend continues. As we develop forests and farmland, impervious surface, roads and buildings, increases in proportion to the forest loss. Washington population doubled between 1962 and 1998, and between 1998 and 2020, we expect to see 2.7 million more people in the state. So what happens to our native soils as we turn forests into cities? We see increasing compaction and erosion, loss of topsoil and soil organisms, loss of soil structure, loss of the natural fertility and disease prevention qualities of the soil, and of course, increase in impervious surface. And this picture taken by Derek Booth really tells the story. These mounds here are left here because the original survey stakes are sitting on top of them. So this 4 feet of missing soil here is the problem. And of course, this is what we're left with: compacted subsoil driven on and compacted further. And then we roll some sod out on it. Phil Cohen took this picture. And we roll some sod out on it and try and sell that project real quick before the grass dies. So all this results, as we've heard, in increased winter runoff, increased need for summer irrigation water and chemical inputs, both fertilizer and pesticides,
and decreased ability of the soil to filter out urban pollutants. Let's look deeper at the stormwater challenges created by this soil and forest loss. In native forests in the Puget Sound region, about half the rain that falls returns to the sky as evapotranspiration. Most of the rest soaks into the spongy soil and travels slowly through the soil to recharge our streams year-round. But after we turn forests into urban and suburban development, only about 15% of the rain returns to the sky as evapotranspiration. A small amount soaks into the soil, but most of the rain rushes quickly off roofs, pavement, and compacted soil and into storm drains. What does that mean for our streams, rivers, and estuaries, and the aquatic life, including salmon that live in them? Under current development practices, we see increased runoff and particularly increased peak storm flows, increased erosion of stream banks and beds, fine sediment choking spawning gravels, increased pollutants from roadways, automobiles, and landscapes, and decreased groundwater recharge. We've been talking about the importance of groundwater as we rush those winter storms off our roofs and roads and on out into Puget Sound. That means that water is not recharging our groundwater, and thus resulting in lower summer flows in our streams. Lower flows and the loss of tree cover around our streams contribute to increased summer stream temperatures and, of course, lower oxygen levels in the water column, including spawning gravels. Again, as we remove the forest, we lose large woody debris, which is necessary for habitat that young salmon and other aquatic species need. And we lose the food supply for young salmon because they eat a lot of native bugs, and native bugs grow on native vegetation. When we have lawns running down to the edge of all our streams, we don't have native bugs falling in to feed the salmon. The impacts are well documented. Declining salmon populations, pollution from sediment, oils, and metals off roads, fertilizers and pesticides washing off our landscapes, erosion of stream banks, widening of stream channels, silting up of spawning gravels, flooding and property damage, and unsustainable landscapes, which need more and more chemical inputs to keep growing, more summer irrigation water, and have increasing plant problems, leading to ever-increasing use of chemical solutions that then impact water quality. Well, that's the bad news. The good news is we're developing a better approach, often called low-impact development. If you want to learn more about it, I recommend you to the Puget Sound Action Team's website on the screen and on my handout that was at the back of the room. A key strategy is to preserve native soils and forests wherever possible, replanting trees and native vegetation, especially in riparian areas, and to restore soil functions in soils that are disturbed during construction. So let's talk about soil a little bit. Soil is alive. I love this because I'm a biologist and it's really cool. Soil is alive with up to 4 billion individual organisms in a teaspoonful of healthy soil. Must be a heaping teaspoonful. Those billions of organisms, tens of thousands of species, create soil functions that we humans care about, including soil structure, natural fertility and disease protection, water storage, so critical to our discussion today, erosion control, stormwater infiltration, and biofiltration of human-caused pollution. To restore that ecosystem in degraded soils, we just need to reduce compaction and add back the lost organic matter in the form of compost to provide food and habitat for those beneficial organisms. A good resource to learn about how all this works is the Soil Biology Primer, available at the USDA website on your screen. Here's one example of restoring soil functions with compost from a study done here at University of Washington. Started in 1994, they measured stormwater runoff over several years from plots filled with glacial till subsoil, what we're often left with on new construction sites. They also measured plots where the till had been amended with compost, and they found up to a 50% reduction in stormwater runoff from the compost amended soil. Also, as you can see from these photos that I took in September, the compost amended soil grows thicker turf, which stays greener without summer irrigation and doesn't require fertilizer or herbicides to keep looking good. Before the presentation today, I went out and looked at these plots. These were put in 1994. It's 2005 now. 11 years later, you can still clearly see that the compost-amended soil is growing thicker, greener, healthier turf with less weed invasion. Compost also has applications as compost blankets to control erosion on steep slopes and establish vegetation, and as compost berms, which are much more effective than silt fence in filtering out sediment and contaminants from construction sites. Here's a picture of compost berms, and again, some resources in my handout that lead you to more about those. Soil restoration with organic materials like compost has a number of other benefits. Biofiltration of urban pollutants, increasing fertility and plant vigor, reducing the need for pesticides and fertilizers, and thus reducing the public health impacts and water quality impacts of those chemicals. It also recycles urban and agricultural wastes into soil builders and reduces pressure on our landfills. And particular to our discussion today, it reduces summer water needs. You've seen this graph before in other forums today. The black line is our water supply. Here we are in the fall and winter, lots of water. But in summer, not so much. In fact, between May 15th and September 15th, our region gets less precipitation than Tucson, Arizona does during that same period. But here's our water use, the yellow curve. Of course, people aren't flushing their toilets more in the summertime. They're watering their lawns and landscapes. That's what this whole peak is, pretty much. Well, the good news is we can cut this summer peak in half by treating soils right, amending soils, using mulches, and by selecting plants for our landscapes that fit our local climate. And that, of course, those plant selections are going to change some as our climate changes too. So to summarize, the soil best practices for low-impact development that we're talking about in new construction, preserving native soil and vegetation, especially trees, wherever possible, and where we do have to disturb it, restoring disturbed soils by tilling in compost and reducing compaction, and also mulching landscapes after planting. I was just looking at some data from some WSU plots where just mulching increased storm water infiltration by 3 times on some plots that they were working on. On existing landscapes, we can also till in compost when replanting, mulch existing beds with organic mulches, and aerate and top dress turf with compost. I'd like to finish with a few examples of successful projects around the region that show us how soil restoration can work. Here at the large Redmond Ridge development in eastern King County, they grade the site to 12 inches below the final grade level, saving the topsoil for reuse later. And also, as you can see in these photos, they leave trees and vegetation wherever possible. Then they install the house foundation and rock pads for driveways. Once the outside construction is complete, they rip in 14 inches of compost-amended topsoil. That way they can quickly install the landscape, plant grass and shrubs, and have their house ready to sell as soon as the paint is dry. And when I came back a week after I took this picture here, this house was sold. They get a premium price because of the great landscape appearance, and they manage stormwater and recharge groundwater effectively too. Here in Seattle, we've been retrofitting neighborhoods that had drainage problems with these natural drainage systems. They use compost-amended soil and swales to slow and infiltrate stormwater. On the oldest C Street project, we've seen a 98% reduction in runoff since the swales were installed. Property values on this street have also risen as a result of improved landscape appeal. Again, lots more, including technical specifications at the website on your screen. The Washington State Department of Transportation now uses compost on all new projects. They've solved persistent erosion problems, created landscapes that establish more quickly, and are cheaper to maintain. Here's a couple examples. Over east of Chelan, this slope was slumping every year out onto the roadside during the winter time, requiring very expensive fixes. And the landscape and the property owner at the top of this hill was starting to get kind of nervous. A problem persistent over many years they solved in one winter season by coming in the fall, spraying in compost, several inches of compost with seed incorporated into it, successfully established vegetation. They ran out of compost in that process. Here we are next spring, successful vegetation and no erosion on the area where the compost was applied. Where they ran out, erosion continuing. They came in and finished the job with compost and seed application and permanently solved a problem that was costing them $10,000 or more every winter to solve. Here's another site. I love it when they went out of compost because we see the results. Here's a site where they put in a compost blanket with seed. Only a week later, where they ran out of compost, real erosion starting, they came in and finished the job, problem solved. Here's one study the Department of Transportation did where a 10-foot wide strip, just 10 feet of compost amended soil, taking the runoff from 2 lanes of Interstate 5, filtering and infiltrating that runoff. They cut total runoff by 60%, as shown in this graph, and you can see that peak runoff has really been cut. And they also reduced a wide range of contaminants by 60 to 90%. And that contaminant reduction increases over time in the amended soil. Restoration of degraded soils with compost can also help in restoring forest vegetation, such as in this stream corridor in Seattle. In this case, we apply compost as a surface mulch, either spreading it or blowing it in, and then plant through it. Steep slopes in the Snoqualmie Pass area have also been successfully reforested using compost blanket applications. The soil restoration techniques I've shown you are just the beginning of the solution and only one set of strategies that we need. But they can serve as a foundation for restoring native forests and wetlands and the ecosystem functions that we all depend on in this region. In conclusion, soil and forest form a green infrastructure that we will depend on more and more as population grows between the mountains and the Sound. They provide our water supply, they slow and infiltrate stormwater, they filter out urban pollutants, and they keep our landscapes healthy and sustainable. Our challenge is, first, to find ways to protect existing soil and forest resources wherever possible, but also to restore soil and ecosystem functions in our urban areas and wherever we build. The good news is we know how to do it. The question is, will we? Thank you. For more information, go to the website on your screen.